After, so this is lecture number 4 of vectors. In lecture number 3, we had completed up to position vector of a point with respect to given point. In this lecture, we are starting with the displacement vector. So after position vector of a point with respect to given point, the next topic is displacement vector. So here we have a point O. In space, I have 2 points A and B. I have 2 points A and B in space. Position vector of point A with respect to O is this vector. See, because it gives me the position of vector A. It gives me, this vector gives me the position of vector A with respect to O. I call this as OA bar, or I can simply call it as A bar. Okay, because O is the common initial point for all. So I will simply call this as vector A bar. You know, OA bar is A bar. A bar is the position vector of point A with respect to O. Then position vector of point B with respect to O is this vector. This is position vector of point B with respect to O. This is vector B bar. You know, OB bar is B bar. So you have position vectors of point A and point B. What now I go for is, see, these 2 points A and B are in space. Now I move from point A to point B. I move from point A to point B. What do? I have a displacement from point A to point B. So what is AB bar? AB bar is a displacement vector. It is known as displacement vector. What is important in displacement vector, that point A and point B, which are the initial and terminal points of AB bar respectively, none of them are the reference point. Try to understand. AB bar has initial point as point A and the terminal point as point B. Now in AB bar, none of the points, that is neither A nor B, none of them are reference points. The reference point is here, which is O. I call AB bar as a displacement vector. AB bar is a displacement vector. Okay. Now what I do is, in this triangle, I am now having a triangle OAB. I will apply triangle law of vector addition. So here I write here by triangle law of vector addition. By triangle law of vector addition, see what I get. I get here, look at the triangle OA bar. See, OA bar plus AB bar. OA bar plus AB bar. Look at the diagram. Okay, don't write blindly. Some students, you know, they don't understand anything and blindly they write AB bar is equal to A bar plus B bar. How come that? Rubbish. How AB bar is A bar plus B bar? They write anything. You have to follow here. You move from point A, O to A, and then A to B. Look at the arrows, you know. Okay. OA bar, you have OA bar plus AB bar. So OA bar plus AB bar is OB bar, O to A to B is same as O to B, is OB bar, right? That is A bar plus AB bar equals to B bar. So you have AB bar as B bar minus A bar. And this is what we were working on. This is what I was working for. You know, this is what I was working for here. See. So what you got? You got AB bar as, I repeat that once again, AB bar as B bar minus A bar. So displacement vector. So here I will write, therefore, AB bar, which is a displacement vector, it is nothing but position vector of point B minus position vector of point A. Point A. So what is AB bar? It is B bar minus A bar. AB bar is B bar minus A bar. AB bar is B bar minus A bar. You can extend this particular concept to various other vectors. Like you can have, now you can have here, see, I can have here PQ bar. I can have here PQ bar as Q bar minus P bar. I can have here MN bar as N bar minus M bar. I can have here RS bar as S bar minus R bar. Okay. I hope you followed this. After, after the displacement vector, the next point we will take is vector in two dimension. See, we are going to now do vector in 2D. 2D is two dimension. Two dimensions. So in order to do vectors in two dimensions, what I will do here is I will draw the x and y axis. Remember, most of the questions and concept in vectors are taken as vectors in three dimension. But in order to begin with vectors in three dimension, first we have to begin with vectors in two dimension. So I will give you the concept for vectors in two dimension, and then we will move to vectors in three dimension. So here I have, this is x axis, positive of x, negative of x. This is positive of y and negative of y. Okay. They intersect each other at point O, which is origin. Now, what I'll do next is I shall take one unit as, I will take one unit as this length. So this is one unit. This is one unit I'll take here. Now, see, deliberately I am making it in such a way that you understand that each such segment is a unit on x-axis. Now, as I took it on x-axis, similarly, it will also be on y-axis. It will also be there on y-axis. This is one unit on y-axis. So as I took it on the positive direction of x and y axis, I can take it also on the negative. So for time being, let us take it on positive only. So 1, 2, this is 3, 4, 5. Here I have 1, 2, 3, and 4. 1, 2, 3, 4, 5. 1, 2, 3, and 4. Same way here you will have negative 1. If I'm taking it on negative, so this is negative 1, negative 2, negative 3, negative 1, negative 2, negative 3. Now think, we are learning vectors in two dimensions. That is, see, we are going to now have vectors like this. See, this is a vector in two dimensions. That is, it is in xy plane, a vector in two dimension. See, these all vectors are in two dimension. Okay, these are all vectors in two dimensions. So we are going to learn such vectors. Now, in order I define these vectors, in order we define these vectors with full expression and with full details, it is important that now I define a unit vector along these two axes. Along x-axis and y-axis, it is important that I define the unit vector. So see what I do. I take a vector in the positive direction of x-axis. I take a vector in the positive direction of x-axis. You see this positive direction of x-axis. I take a vector in the positive direction of x-axis, and that has magnitude equal to 1 unit. It has magnitude equal to 1 unit. Such vector is known as, it is named as I cap. You know, this vector is I cap. Why? See, this vector is I cap. So far as it will remain in this direction, see, this direction. I can take it anywhere, but look at the direction. The direction is always in the positive direction of x-axis. I will name this vector as I cap. See, if I'm keeping it at origin, it comes to 1. But when I keep it at 1, it will come to 2. If I keep it at 2, it comes to 3 because it is one unit vector. It is a vector having magnitude equal to 1 unit. Okay. And this vector, we will name it as I cap. What is name of this vector? The vector is named as I cap. I cap. Okay. If I have a vector which is having magnitude equals to 1 unit, but it is in opposite direction of I cap, then what we will name this as? This vector is named as negative I cap. It is minus I cap. Okay, this is minus I cap. So whenever I say I cap, you should understand that we are referring to a vector which is a unit vector in the positive direction of x-axis. It is also known as a basic vector along positive direction of x-axis. When I go for a unit vector in the direction of positive of y-axis, see, I mean this vector. If I go for this vector, a vector in the positive direction of y-axis, we will call this as j cap. It is j cap. This vector is j cap. And if I go for a vector which is unit vector, but it is opposite to j cap, that is, it is in the negative direction of y-axis. It's in the negative direction of y-axis. We call this as minus j cap. It is called as negative of j cap. Okay, remember these all vectors have magnitude equal to 1 unit. So the moment I say j cap, you should understand that it is a vector which is having magnitude 1 unit and it's in the positive direction of x-axis. Okay. Now, what I do here is I take a vector. See, I take a vector here, which is this big. I take a vector here, which is this big. I take a vector here, which is this big. And this vector is, as you know, it originates from the origin. Its initial point is O, and say the terminal point is P. So what I want to know is OP bar. I want to know OP bar. That is, I want to express the vector OP bar completely, okay, with full details. Now, what I will do for this is I shall draw the perpendicular from point P on x-axis. I shall draw a perpendicular from point P on x-axis and from point P on y-axis. Now, you know, when I do this, I get the coordinates of point P. The coordinates of point P are 3, 4. I get coordinates of point P as 3, 4. Now the perpendicular which I draw from point P on x-axis, say this one I call it as point M. This one is say point M here. This is point M and this one is point N. Okay. Now I want the full expression for OP bar. I want the full expression for OP bar. Now there are two ways I can reach to OP bar. I can go to OP bar. I can start from, see, OP bar is nothing but from point O to point P. Now I can reach OP bar in two ways. I can start from O and go up to M. I can start from point O and go up to M. Okay, this is in one direction, that is OM bar. And after which, what I will do is, after that, I will start from M and go to P, So I understand here that OP bar can be written as OM bar plus MP bar. OM bar plus MP bar. OM bar plus NMP bar. So what is OM bar? Try to get this. See, I understand that OM bar, look at the vector OM bar. I mean this vector is OM bar starting from O and up to M. Now you understand that if I take 3 times of I cap, see OM bar, magnitude of OM is 3 and it is in the direction of positive of x-axis. So if I manage to have three I caps, I'll be getting, if I manage to have 3 I caps, I'll be getting the vector OM bar. See, this is 1 I cap, this is 2 I cap, and this one is 3 I cap. See, 3 I cap is nothing but OM bar. OM bar is 3 I cap. What is OM bar? OM bar is 3 I cap. Then I have to get the vector MP bar. Look at the vector MP bar. MP bar is in the positive direction of y-axis. Further, what I notice is MP bar is same as ON bar. The vector ON bar. Look at this. The vector ON bar. MP bar is same as ON bar. I write here. I write MP bar equals to ON bar. And what is ON bar? What is ON bar? You will notice that if you could get three vectors which are in the direction of j cap, sorry, not 3, 4 vectors. So j cap, see, these all are j cap. You have total 4 j caps. You have total 4 j caps. So what is ON bar equal to? ON bar is collinear. ON bar is in the direction of j cap and it is 4 times of j cap. ON bar is in the direction of j cap. Look at ON bar. ON bar is this way. See, this is ON bar. So it is in the direction of j cap and its magnitude is 4 times of j cap. So what is ON bar? ON bar is 4j cap. Now what I will do is I will substitute these two in first. So see, I get here OP bar equals to OP bar, I get here, what do I get? I get OP bar is equal to OM bar, which is 3 I cap plus MP bar, which is 4j cap. So here you have, see, this vector is 3 I cap, 3 I cap, 4 j cap. This is, this vector is 3 I cap and this vector is 4 j cap. I hope this is clear to you. So from this, what I conclude, look at this. I conclude here that if a point in two-dimensional, we have a conclusion here. See, the conclusion here is the position vector. This is, see, you got OP bar. OP bar is nothing but position vector of point P with respect to O. OP bar, what you got is nothing but position vector of point P with respect to O. So here you will write the position vector of point P 3 comma 4 is OP bar equals to, check, 3 I cap plus 4 j cap. Now when you have the coordinates, you don't have to do all this. You simply write x coordinate multiplied with I cap plus y coordinate multiplied with j cap. So this is P bar equals to 3 I cap plus 4 j cap. So in general, how would we write? See, in general, I can write the position vector. I can write here the position vector of A x1 comma y1 is OA bar. It is OA bar, which is equal to A bar equal to x1 I cap plus y1 j cap. X1 I cap plus y1 j cap. This is all about vector in two dimension. This is all about vector in two dimensions. So for example, suppose I have a point here B. B is minus 3 comma 4. So what is OB bar? OB bar will be minus 3 I cap plus 4 j cap. If I have a point C which is minus 7 comma minus 8, point is C minus 7 comma minus 8. So what will be OC bar? OC bar will be minus 7 I cap plus minus 8 j cap, which is minus 8 j cap. So here we have done I cap and here we have done the vectors in two dimension, which are, you notice that all the vectors in two dimension are expressed. They all are expressed with the help of I cap and j cap. I cap and j cap. Okay. Now students, here I got OB bar. As you know, OB bar is written as B bar and OC bar is written as C bar, right? Now, if I would like to have a displacement vector, how would I do it? Suppose I want now BC bar. As you all know, BC bar, just now we did, BC bar is C bar minus B bar. So you already have B bar and C bar. What is C bar? C bar is minus 7. See, this is point B, this is point C in 2D plane. You want a BC bar, that is, you want a vector which starts from point B and it goes up to vector point C, which is a BC bar is a displacement vector. BC bar is C bar minus B bar. So what is C bar? C bar is minus 7 I cap minus 8 j cap minus B bar, that is minus of 3 I cap plus 4 j cap. So when I open this, I get minus 7 I cap minus 8 j cap plus 3 I cap minus 4 j cap. So finally I get minus 4 I cap minus 12 j cap. This is vector BC bar. This is vector BC bar.